Hi guys, my name is Loretta. I'm an engineer at DesignPoint, and today I'm going to be talking about 5 ways that a purpose-built tool can help speed up schematic design. The goal here, as always, is to eliminate as many bottlenecks in the design process as possible. We're actually going to break this down based on where a majority of the time goes. So we're identifying potential bottlenecks, and then I'm planning on showing you how we can get around these. The 5 main bottlenecks we're looking at today are planning our project or not, redoing work that has already been completed, documenting our work, making design changes, and communicating and collaborating. So the first place we might spend time is planning out our project. This one is a double-edged sword though, because most of us have 2 options and neither one is really very good. The first option is to go through with planning, make a couple of high-level diagrams, and then we essentially move on to actually drawing our schematic. Problem with this is that it is potentially wasted time. We can't really reuse this work, right? So the temptation is to skip the planning phase and go straight to drawing the schematics. Of course, we might end up redoing more work with this method because we missed something that we could have seen if we planned things out. Also, we might end up having to go back and create high-level diagrams at some point anyway because we're trying to communicate with a management team or a mechanical engineering team, and they don't read or understand schematics. So again, we're wasting time. Okay, so let's take a look at how using a purpose-built tool like SOLIDWORKS Electrical can help us with this issue. Okay, so within SOLIDWORKS Electrical, we have access to an optional tool called the line diagram. This is really just another sheet type. And what it does is it gives us access to a library of symbols that are really high-level representations of our components. So for example, let's grab a terminal strip and place that on our page. And we need some motors to hook into that. So I'm going to grab another symbol and we'll grab a motor symbol. You'll notice it's really easy to find these things based off of the classifications that we've set up here on the left. And as soon as I place it on my page, it intelligently selects a root mark. So motors are going to be in, terminal strip was TB, and it designates a number to it. We can even add in a little bit more detail here. If we know the manufacturer part, we have access to our library of manufacturer parts here. We can grab one and attach it to the symbol. And what that does is it allows the symbol to update with the metadata, and it also pushes that physical part into our database of things that we need to order. From here, we can actually just copy and paste things, and the mark itself updates so that it's unique based off of a equation that we gave it. So we can add in several motors here very quickly, and we can connect these things with cables. And you'll notice I'm not going to click exactly on the edge of this. I'm going to click a little bit off the edge of this, and it's still going to make a perfect connection. So it makes connecting these things really, really simple and easy. From here, we can continue adding more symbols. We can take this and scale it down and move it over, or we could actually add in a physical cable in between objects. Again, just accessing a library of cables and just sorting by any number of things. For example, we could just sort by a 4-conductor cable. We can even add physical connections between objects, and we can add terminals here. So you can see we can add a lot of detail during the planning phase, and it's really not wasted. We're going to see that later. This work is never wasted. So let's fast forward here really quickly and see what this looks like a little bit later on. Okay, so here we can see our completed planning diagram for this project. One of the great things about this is it gives us a really early look at the bill of materials. And that's really important sometimes if some of these items have a long lead time. We're going to look at reporting later, but I wanted to give you a preview of this. You can see we already have a full list of the parts that we're going to be ordering. So we have everything we need to order this. And at this point, we can actually go ahead and export everything to Excel. So we can just grab our bill of materials by manufacturer save it to the desktop. And you can see it opens up in Excel, so we can pass this along to our ordering department and maybe highlight items that we know that are going to take a little bit longer to order. Okay, so what we just saw was how using a purpose-built tool like SOLIDWORKS Electrical can help us get a jump start on our schematics. More on this later. It helps us to predict and prevent potential issues down the road. And this tool allows us to quickly and easily place orders with a long lead time. So awesome. We've addressed the planning bottleneck, and we're moving on to look at how we can stop redoing work. But first, let's take a look at why this is important and how most of us are doing this today. So first of all, for all of you out there that are still drawing your schematics by hand, there's obviously no way to reuse your work, short of tracing symbols from a sheet. If we are using some sort of CAD, maybe we can copy and paste items, but it will take time to find what we want, and once it's copied, we'll still need to manually renumber and update metadata. So both of these options end up wasting a significant amount of time. The other problem with this is that since there's no unified library of work that has already been completed, individuals end up defining their own standards, which leads to inconsistencies between engineers and ultimately siloed knowledge that is difficult to pass on to new team members. So let's take a look at how we can address this challenge. It's a big one with SOLIDWORKS Electrical. One of my favorite things about SOLIDWORKS Electrical is that we never have to start from scratch. In fact, when we create a new project, we're always starting from a template. That template can have as much or as little information as we want. It gives us a nice starting point for our project. When we unarchive a template or open a template, what happens is SOLIDWORKS Electrical looks back at our server machine, grabs the information that it needs from this central location to create our project structure. You can see here, we've brought in a cover page, a drawing list. We've already pre-done several of our schematics. And just to make things a little faster, I left our line diagram in there that we created during our planning phase. So maybe we need to make a couple changes here, but then we can move on to our schematics and drawing things out. You can see I've added some power lines here. We need to add our motors in on this drawing. So to do that, we're just going to draw a few wires in here. And then we're going to start adding symbols to our schematic page. So to do this, it's exactly the same as it was on our line diagram, but we have a different library of symbols here that are available to us for our schematics. The cool thing about this library is that it is a central library, so it's stored on a server, and anybody that is connected to this server has access to the exact same symbol set. So we can build up our company standards with standard symbols, very quickly sort through these symbols, find the one we need, and add it to our project. We can also associate this to something that we added in our planning phase. So for example, this circuit breaker is actually the same thing as circuit breaker 304 that we added on our line diagram. And all the information updates with it. So we don't have to reassociate a part or go back and check to see what part it was that we added to our planning phase, or even pull in our terminals. All that stuff updates for us on the symbol. There's also an even easier way of adding symbols here. You can set up palettes with the symbols that you use the most. For example, a contactor, drag and drop and place it on your page, and then you just reassociate it again to whatever you had in your planning phase. Last way of adding a symbol, it helps to standardize even more. We can actually take a look at our component tree, and we can find the component that we want to add. For example, motor 304. Right click and insert symbol. There's going to be a symbol associated to that part. It's going to pull in the same symbol every single time for the same part. And it's going to pull the information again from our planning phase. We need to add some terminals in between CR304 and M304 to match our line diagram. You can see that there's a cable there. So pay close attention to what happens when I add our terminal strip in between these two, I guess between CR304 and M304 in the schematic. All I'm going to do is draw a line across my wires, hit OK, and everything updates. The really cool thing that happened here is you'll notice cable 1 was added in between these two. That information propagated from my planning phase into my schematic automatically. So that's awesome. All of that was really easy to do, but we have a few more motors to detail down here, and we really want to do exactly the same thing. So another great thing about SOLIDWORKS Electrical is it allows us to reuse our work through something called a macro. There's a macros palette over here. What we can do is just drag a box over the elements that we want to reuse, and then drag and drop it into this palette. We're going to give it a name. This makes it fully searchable, and it's going to put it into our common library. And then we can add as much or as little metadata as we want. So now we can actually reuse this across projects and across users. And it's really, really easy to search for this. All I have to do is open up our Find tab. I'm just going to look for MOT, and I can see all of the macros that I have that start with MOT. So now I can just drag and drop this onto my sheet, and our Paste Special dialog box comes up. The cool thing about Paste Special is that it actually allows us to choose which objects in our macro we are copying and pasting directly, and which objects we want to associate to things that already exist in our project. So, for example, for components, we want to create a new mark. We're creating new components. Or we can come over to the Component tab and say, actually, the components that exist here should be associated to components that already exist in my project. So, for example, CB308 here and CR308 and M308. We click on Finish, and everything updates for us automatically. I'm just going to move this down just a tad. There we go. So as you can see, we can just redo this process for the other items, and we can also bring in other elements. Like we could bring in a full circuit over here. Maybe we want to move that up, and we know we need a transformer, so we'll look for TRANSF. Drag and drop one of those in. And as you can see, we can very quickly build up our project and find things in this common library. So we're not redoing work at any point. Okay, so what we just saw was that we were able to start with a template, reuse the work that we did when planning things out. We are constantly working from a common library, and we can quickly search through this common library for existing part symbols and groups of these called macros. Furthermore, the program automatically updates metadata for us after we place these elements on our page. So there we go. Another bottleneck has been widened, and we're ready to move on to tackle documentation. Documentation is probably the most boring part of the design process. Most of us are doing this manually today, which means it's highly error prone. It takes a lot of time. It kills a lot of brain cells, and we end up with documentation that is, let's say, less data rich than it could be. Furthermore, our documentation won't have any direct link to our schematics, so we usually end up doing it either one time at the very end or not at all, since it's not intelligent and changes won't propagate to the documents, so things aren't staying in sync. So let's take a look at how we can address this using a purpose-built tool. All right, so now that our schematics are complete, it's time to start the documentation phase. For me, this always starts with numbering all of my wires. Just a huge manual process going through and numbering these by equipotential. In SOLIDWORKS Electrical though, it's just a matter of clicking on Number New Wires. There are predefined formulas within these wires that determine how they're actually going to be numbered. You can see all of our power lines are numbered a little bit differently than how we number our wires for control. So that's awesome. That's actually been done across the project. And now it's time to move on to getting our bill of materials. Again, this takes a lot of time to do manually. In SOLIDWORKS Electrical, we actually already have a bill of materials. We saw that after the planning phase. We also have a drawing list, a list of all of our cables from to information, a list of our wires, and a list of our wires specifically connecting into our PLC, because we need a little bit more information from this, including the address of our inputs and outputs. So super simple at this point. We just click on generate drawings and we let SOLIDWORKS Electrical do all this work for us. We also saw earlier how we can export them to Excel. We can export them to Excel, TXT, or XML, or PDF really. But now we're almost done generating our reports. The last report that I like to generate is a terminal strip drawing. This just gives us a little bit more information on our terminal strips in particular. It's another nice thing to hand to manufacturing so that the design is really clear. So all of that went into our reports folder. Let's take a look at what we did. So here's our bill of materials. We set it up so that it would automatically split by manufacturer, and we wanted all of our mark information, the description, and the quantities. Here's our list of cables. We've got from to information, we've got core information, we've got the wire number. The great thing about these reports is that they're customizable, so we can bring in as little or as much information as we need. And then of course a list of wires, origin, destination, wire number. We've got some duplicates here, of course, because the equipotential is the same across these. Finally, our PLC connection list. That includes the address, wire number, origin, destination, and then the terminal strip drawings. These are super useful. So you can see for TV1, we can see all the terminals in TV1. We can see the cable that's connected in here, and even the component that's connected on the other end. And so on and so forth. So really within seconds, we numbered our wires, generated a ton of documentation in terms of bill of materials, cables, list of wires, PLC connection list, and we even created terminal strip drawings. Okay, so what we just saw was a huge improvement over the manual way of documenting our work. We've got automatic, intelligent, data-rich documentation, and it literally takes seconds to produce and to update. Now that we've busted that bottleneck wide open, let's take a look at what happens when we make design changes today. This is a big one because design changes are inevitable for most of us. The problem with design changes is that they are often difficult to keep track of, and a change on one sheet might also mean we need to update 7 others. Because of this, there's a lot to keep track of, and it's easy to make a mistake. For example, if we make a change to a part being used for a relay on one sheet, let's say we start with the contacts. We also need to update the sheet with the representation of the coil in additional sheets with the contacts, and we need to update the bill of materials and possibly terminal strip drawings and possibly our from to list. And if we forget to do any of these things, we're in trouble. So let's take a look at how this is addressed in the software. So now that our project is complete, we look back and we realize, oh man, we got to make a change. We don't need one of these motors. We want a different part for one of our relays, whatever it is. One of the great things about this program is that revision control is built right into the application. So we can just create a new revision, give it a description, click on OK, and then make the changes we need to make. So the first thing I'm going to do is I'm going to remove motor 318. We can see that it is on this page. I'm just going to remove that whole line. but it's still in our planning phase. So I'm just going to go to that motor in our planning phase, and we're going to remove the cable, controller, the relay, and all these things here. We can even delete the cables, add a couple new cables in here, maybe even move things over actually. Just make a couple of changes. Now we have a gap. We don't have cable 4. So at this point we can actually renumber our cables. And now we no longer have that gap. All right, so first change completed. The second change is that we want to change the part we're using for the relay for CR313. So to do that, we're just going to take a look at the part, delete it, and search for a new one. Now this relay is actually represented in several different places. If we were doing this manually, we would have had to update all this metadata here and also update it everywhere else. But as we can see here, we go to the other representations of it, all the information is updated as well in these other locations. Now the final step for this update is we want to update our reports, right? Again, this would be a manual process if we didn't have an intelligent software here. So we can actually just right click and update our report drawings. And now we can see that our new relay is now part of our bill of materials, and we only have 4 motors. Okay, so what we saw there was integrated revision control, allowing us to communicate changes we make quickly and easily. Any changes made to a project are automatically propagated across sheets, and that's huge. Additionally, the program keeps track of the details like wire numbering and component numbering for us. And if we want to renumber things, we've got tight control of that as well. Now that we don't have to worry so much about making design changes, let's take a look at communicating and collaborating across a team. Whether we're on a team of 2 or 50, this is a challenge. The first, most frustrating part of the challenge has to do with managing our data. Assuming we don't have a data management system, collaborating on a project is near impossible because it's so easy to accidentally overwrite each other's work. Picking up the phone or writing an email takes time, and it's often skipped. And if we're on a large team, undefined roles inevitably create conflicts. Finally, multiple copies of the same document can cause confusion. So, with all that in mind, let's take a look at how SOLIDWORKS Electrical can help us with this. So aside from the standard searchable libraries that we have and the built-in revision management tools within the product, SOLIDWORKS Electrical puts our minds at ease when it comes to collaboration because there's a collaborative server that makes sure we are not overwriting one another's work. In fact, right here, we can see this project's in red because another user is currently in this project. It happens to be me this time on another screen. What happens is whenever we open a project that's currently opened by somebody else, it tells us that it is currently opened by somebody else, and lets us know that we're not going to be able to access files that are currently opened by the other user in the project. Click on OK, and it opens up the project for us. When we open up our document tree, we can also see which pages are currently being used by another user. So if I double click on power, red indicates it's in use. We can either preview it if we just want to see what's going on, or we could even send a message to that person. So I can message the other user and say, hey, I was hoping to add a couple of motors to the sheet. Can you close it? And what happens is the other user is going to get a notification on their end, and they're going to have a chance to reply back. So the product itself enables communication between users that are simultaneously collaborating on a project, which is really great. The other thing that it allows us to do is it allows us to define roles within the tool. So we're going to come over here to rights management, and we're going to manage user rights. From here, we can create new users, new groups, and then we can give individual users or groups of users access to various functionality. For example, we can restrict somebody from creating new symbols and new parts by making them simply a project editor or a project contributor. Then other users, maybe senior engineers, could have library manager rights or even administrator rights so that they can make all the changes they want. This helps us to avoid conflicts, especially with new team members coming on. We might not want them defining our company standards. We also have a very unique ability to tie directly into SOLIDWORKS 3D using a SOLIDWORKS electrical add-in. I'm not going to get into very much detail about that right now, but it's definitely something to consider if you're already using SOLIDWORKS 3D. There's a direct link between the two programs. Finally, we can link directly into SOLIDWORKS PDM using one of two methods. This allows us to either check our projects in and out of PDM or update our files to PDM, automatically generating PDFs, DWGs, and other searchable documents that our coworkers can use. Awesome. So aside from revision control and unified libraries, we also saw how SOLIDWORKS Electrical's collaborative server will ensure that we're never writing over each other's work. We can also quickly message each other directly in the program, and we can define roles or restrict access as needed. Most importantly, however, we have a single location for data, and as a bonus, we get a direct tie-in with SOLIDWORKS PDM. So there you have it. 5 ways that automation can make your job easier. Plan, update in real time, automatically create documentation, reduce rework, and minimize miscommunication. Thank you all for your time. If you liked today's presentation, please feel free to check out our other videos on YouTube. Visit us on our website at design-point.com. Send us an email at info@design-point.com or follow us on social media. Thanks again. See you next time.